Problem 8.34. Determine the equations of the tangent to f equals the logarithm of 1 plus x squared at its inflection points and plot them along the graph of f. Okay. Now again, see that this function is going to be even. Okay. So we should get an even number of inflection points symmetrical with respect to the y-axis. Okay. In order to get the inflection point, we need to get the derivative and the second derivative. The derivative of this is going to be 2x divided by 1 plus x squared, and then the second derivative is going to be, let's say, 2 times 1 plus x squared minus 4x squared, if I'm correct, divided by 1 plus x squared and this is 2 minus 2x squared, 2 divided by, 2 times 1 minus x squared divided by 1 plus x squared. Okay, the zeros of this are clearly, the zeros of the second derivative are clearly plus minus 1, so these are the inflection points. And let's see, so when x is greater than 1, you have that the second derivative is negative, so you have a concave function. And when x is smaller than 1, and let's see, this compute this with absolute value, because we know it's going to be symmetrical, this is going to be greater than 1, convex. Okay. And then, so for the tangent at these points, right, we have the equation of the tangent is going to be f at a, right? F at a plus the slope at that point times x minus a. That's the equation of the tangent, right? The approximation. F at 1 here, which is one of the points. The other one is going to be exactly the same but symmetrical. F at 1 is going to be 1, actually. No, sorry, this is not the function, this is the original one. F at 1 is going to be the logarithm of 2 plus the derivative at a, which is 1 times x minus 1. Okay, so this is the tangent of 1, and the tangent at minus 1, you see this is going to be minus plus the logarithm of 2, because the function is even, plus, and then this function is odd, so this is minus x minus 1. Okay, so let's see, we have our function here at 1 and 1. It's something like the logarithm of 2, and this is in other words, this is x plus the logarithm of 2 minus 1. The logarithm of 2 is smaller than 1, so let's say that the intercept is going to be like here, right? And let's say something like this, right? Wait a minute. If I ever know how to paint this, and this is symmetrical, right? It's the same but with the negative slope, so it's going to be like this. Okay, that's the tangent. We know that the function is going to have this value here and this value here, and we know that it's concave after that, so it's going to be like this and like this. Okay, below, we know that concave means below the tangent, and over tangent here, we know that at 0, this is the logarithm of 1, 0, so it does something like this. Okay, so you can see how the tangents separate the behaviors between convex and concave, and you know, this is going to go to plus infinity and to plus infinity.